it's all happening on your laptop. So essentially, the sort of thing that you've trained is all sitting on your computer. So it is an interesting kind of fork in the road, where I could imagine a world where if that kind of classifier I'd made for my kids' drawing, would that be something that I could kind of grab and share and post? And so I think that idea of you owning a little model that you've made was very much what we wanted to go for with Teachable Machine, but we haven't quite gotten to that. That's almost the second phase of that, hopefully.
Thanks, Alex.
So the next speaker is Patrick Hebron. He is an associate professor at the New York University and has worked with Creative Labs as well as with Adobe on the implications of machine learning for creative work, and has also published a book around machine learning for design.
Hey, I want to thank the organizers for having me. It's really an honor to be here. Okay. Oops. Okay, so this talks about making machine learning tools more accessible, but it's not about dumbing them down for lay audiences or about creating toy interfaces for toy problems. Obviously, there's a lot of differences between human and machine learners, but we all have ample experience with perhaps the most fundamental element of machine learning, which is that we know how to learn from experience. And in fact, the challenging thing about learning how to teach someone else is kind of remembering how you came to know something yourself. This metacognitive ability is really a very precious and hard-won skill. Obviously, it's very much in the wheelhouse of educators, but it's also a key component of all of our interactions with other people. When we teach our children to ride bikes, we don't rattle off exact programmatic procedures. We instead demonstrate, watch as they approximate the action, and help to direct the child's focus to overlooked aspects of the task. Machine learning tools should help us to do exactly those things for machines so that they can in turn help us to solve problems that are too complex to be addressed by conventional code. And also tools that help us to sharpen these kinds of metacognitive abilities will not only help us to build more useful machines, but they'll help us to understand ourselves more deeply and engage with the world more effectively. So when I say accessible, I mean that machine learning tools should be able to serve as the extension of every human's kind of innate capacity to both learn and teach from experience. Machine learning is a tool for everyone, but in its current form, that's not really all that obvious. Presently, machine learning tools require some programming skills, some understanding of the fundamental techniques in machine learning, the underlying math, and probably also some DevOps skills. And so in combination, this presents a really very high barrier to entry. The first generations of tools have been focused on aiding expert practitioners to manage high performance pipelines at really very granular levels. And they've also abstracted the demands of machine learning into conventional programmatic structures, even though in many ways there's a kind of incongruity between the deductive mentality of conventional code and the inductive mentality of machine learning. The skill that I think is not really yet accentuated in machine learning tools, aside from say the things that Alex was just talking about, is that these tools don't accentuate the skill of curriculum design or the process of curating a learner's experience of a complex concept and bringing forward its meaningful elements. In my teaching work, I've found that often a person's math and programming background is in a lot of ways not the best predictor of how they will take to machine learning work, applied machine learning work, and that in many cases the most captivating projects come from students who are clear writers or designers. And I think this is because what makes a machine learning project successful is the student's ability to articulate a learning problem, how a particular concept can be demonstrated through a particular presentation of data. And this was actually, oh wait, that doesn't look so good, but this was actually published just a few days ago. As mechanisms for neural architecture and hyperparameter search become more robust, then the skill, the sort of current skills in machine learning work kind of become somewhat less vital to applied work, and the skill of articulating a learning problem becomes all the more. I think this is sort of analogous to perhaps in the first 20 years of computer science, to be a programmer, you really had to basically understand how to implement a compiler. And as we've moved towards higher level languages, that's no longer necessary. I think we can sort of see the type of work that goes into designing a neural network today as being that kind of sort of compiler design aspect, and so the sort of more central skill will become curriculum design, if you will. So hopefully this kind of next generation of machine learning tools will be able to serve two audiences. It will help novices in the sort of conventional aspects of programming and machine learning to be able to experiment and explore. And at the same time, it can also, I think, help expert practitioners to sort of work within a framework that is more natural to machine learning rather than sort of being built upon kind of the conventional code mentality. Traditionally, a programming language is treated as distinct from IDEs and other tools that are essential to writing software. And these delineations were, probably already pretty outdated with the advent of graphical computing. But in the machine learning age, they're becoming even more so. I think, one place where we can already see the need for kind of a more holistic programming environment is in the efforts of DeepMind and OpenAI and others to build simulation environments for training reinforcement learning systems. These are sort of game or design or physics kinds of environments, and becoming sort of more and more central in this sort of graphical and physical context to building machine learning systems. Of course, Jupyter Notebooks, MATLAB, Mathematica, Swift, processing, Scratch, and web development tools have already kind of started to blur these distinctions between the text editor and kind of a more cohesive environment. But there's a long way to go. The purpose of this is not only to make the interface more palatable to the human user, but also to sort of bridge the gap between the computer's understanding and kind of experiential nature and of course the humans. So deeper mechanisms for communication shouldn't be tacked on to the existing interfaces or auxiliary libraries. They should be brought into the center of our tools. And we should also kind of take this paradigmatic shift that's brought about by machine learning as cause to kind of rethink numerous aspects of software development. If we're making one change, why not make a bunch? Okay, so I'd like to show you sort of a little bit of a project I've been working on and treat it kind of as an example of how these kinds of ideas might be implemented. Some of the stuff we'll talk about are things I've already implemented. Some of them are sort of longer term horizons, and I'd be happy to show any of you where the current software is. But for the purpose of this discussion, don't want to sort of focus on that divide and instead sort of talk about this as a whole vision. So I call it FOIL. And it's supposed to be kind of a combination of machine learning and creative coding platform. And it's an attempt to close the loop between programming, machine learning, and design tools in a single platform that kind of integrates all of those aspects that we've talked about and builds a pathway from novice to expert. It envisions a multi-tier approach in which lower level features can be used directly by more experienced users or can be composited together to be used by less experienced users. And as users gain experience, the idea is that these components are not sort of impenetrable, but instead can be kind of inspected under the hood. So I think we see some of this going on with with TensorFlow's estimators and of course Keras and so forth. And I guess one extension of that would be to think about sort of graphical representations too there. So this is its kind of expert mode or current state, and which is roughly equivalent to Jupyter Notebooks, but trying to sort of integrate all of these components into one place. This is sort of the jumping off point for the higher level functionality I'll talk about in a moment. So one of the most intimidating things about entering machine learning work is the process of gaining an intuition for the role that certain mathematical operations play in mechanizing inductive learning processes. It was great to see Alex mention Seymour Papert, and I won't make a specific mention here, but he's sort of the spiritual guide of all of this. So I think that really the challenge of gaining this intuition is really not just limited to those who who are mathematically uninitiated. And one way to support this claim is to look at the more or less 300-year gap between Leibniz's first mention of the chain rule in calculus and the advent of the backpropagation algorithm. So that is to say that even with an understanding of the underlying mechanics and mathematical tools, it's not always obvious that a particular application of those tools will yield a kind of a useful result when applied to a system that's too complex to compute mentally. So to overcome this challenge, we need to lower the barrier to experimentation. And of course, unguided experimentation is in many cases unlikely to arrive from scratch at the kind of complex formations we see in modern neural networks. But when an experimenter starts from known mechanisms and moves outward, sort of as guided by their project interests, then it becomes possible for them to sort of explore this space in kind of a more organic manner. And I think with the current tools, this is somewhat challenging because a lot of the examples that we would seek to learn from have been sort of codified by experts in a very obscure kind of way, at least from the point of view of someone just entering it. So in terms of architectural components, I think it's important to take sort of a multi-tier approach and provide novices with extremely high-level building blocks that address the basic categories of learning problems. Early in their experimentation, it's sort of unlikely that they will have cause to need something other than these kind of generalized one-size-fits-all building blocks, because they haven't yet kind of encountered the sort of deviations from that. And so a high-level interface with lightly customized templates and under-the-hood automations will allow novices to sort of explore this idea of how to kind of frame a learning problem. And then as they gain expertise, they might have sort of cause to start digging deeper, and of course inspecting these components and going to sort of lower levels. I guess we could sort of call this the Keras layer and this the TensorFlow layer. So as they gain intuition and kind of an understanding of how machine learning works through this perspective of, let's call it curriculum design, then there may be sort of eventually kind of a cause to understand at the lower level what's going on in sort of the operations and start to begin to think about how to customize those things for themselves. Then as an extension of these building blocks, the tool also, I think, needs to provide a really extensive model zoo and the infrastructure for users to share models. So think of this in sort of three kind of tiers as well. The first being that we would have specified and trained models, meaning ones that can be sort of just pulled directly off the shelf and used for, say, image recognition task or something like that. A specified and untrained model would be one where sort of the architecture is pre-specified to say particular input image dimensions and so forth, but would be untrained. And then at sort of the most general would be kind of an unspecified and untrained model, which would be, for instance, say a multi-layer perceptron architecture that could be sort of specified to any particular kind of problem. Then similarly, given of course the primacy of data in given the primacy of data in constructing machine learning systems, the development tools I think should also provide building blocks to facilitate the loading and manipulating of data. Array manipulations, one of the most common tasks performed by computer scientists, but it's also one of the greatest sources of frustrations for novices, and even seasoned developers, find it very time-consuming to understand, someone else's ad hoc code for slicing complex data. And depending on what the user wants to learn from the data or what tasks she wants to perform through it, the question of how to slice the data and what neural architecture to use are very much interrelated considerations. And so for this reason, it's important for the components in data manipulation to be closely aligned with the tool's architectural building blocks. At the highest level, the tool should provide interactive mechanisms for selecting files from files or media streams. At sort of a more slightly lower level, it should be loaders for common file types and data sets. And then at the lowest level, of course, you don't want to inhibit sort of current methodologies. And so, you should also give programmatic tools for accessing the file system and manipulating arrays in the conventional sense. Within this, I think, it also makes sense to support data set maintenance. So you would have, kind of watchdogs that could look for changes to remote or local file directories and perform automatic retraining of models when updates occur. And then finally, sort of embedded directly within this kind of environment, that you would include crowdsource tools for, either for data acquisition or for cleaning. Okay, so the next idea I want to talk about is something I call directives. And so the idea is, in a conventional programming language, the developer starts with a nearly blank slate and needs to conceive of a set of interrelated abstractions in order to address some kind of desired programmatic behavior. This open-endedness is of course a really great thing, but it also it requires us to navigate on our own each component decision in relation to each other and in relation to the whole. So directives are a mechanism for helping developers to structure their thinking without imposing any one specific abstraction on it. In the most basic sense, directives are comprised by a set of widgets for soliciting multimedia inputs and presenting multimedia outputs to the user. The author of the directive uses these widgets to compose a kind of decision tree or guided process through which the user can respond to each decision point in the most appropriate modality for the task at hand. Visual information can be communicated visually, and textual information can be communicated textually. When a specific numeric value is needed from the user, a slider could be presented so that the user can experiment within a specific numeric range and see its effect applied immediately and in context. Rather than offering one kind of preordained mental model, by offering these in sort of a directive zoo, if you will, would provide developers with a range of possible abstractions for a variety of component problems. And alternately, of course, you can write your own directives. And the process of doing so, I think, is sort of analogous to, the sense in which kind of properly formulating a question is half the work of answering it. So directives are meant to facilitate software development processes as kind of a crowdsourced design pattern, but they're also something that can be employed within user-facing applications to facilitate interactions with trained models or other features of an application. In this sense, directives are meant to serve as a way of kind of blurring the distinction between the acts of writing and using software. In the context of writing it, help to make a more manageable experience for the developer by breaking the process into smaller tasks. And in a user-facing context, they provide kind of a more natural format for the kinds of multimodal interactions that we'll need to have with intelligent applications. Directives could be written explicitly as code, or as shown here, they could be created using directive-making directives that would ask, questions like, what should the user do next? A very kind of meta approach. Directives would also be something that could be configured to do data collection under the hood in order to feed a learning decision tree, much like the digital version of the game 20 Questions, which is shown here. This, I think, in a way could bring sort of a new way of looking at the value of open source software, which is that by sharing these kinds of processes with other users and allowing them to engage with them, their data is informing the learning decision tree and therefore making your shared software that much more effective. So the last group of things I want to talk about is sort of the integration of sort of creative coding or design tool elements. Where we've moved through machine learning well beyond kind of the confines of keyboards and mouse into a machine's ability to understand images and audio streams and videos. And these forms of media are very critical to the training of machine learning systems and also to our subsequent interactions with them. And our programming tools today provide very little assistance with this. To build a data set, we generally kind of, are working somewhere between the operating system's file system, conventional design tools, some ad hoc code. And so I think, both in terms of sort of curating data sets and in terms of things like doing, visualizing training metrics, makes a lot of sense to start kind of embedding these things into the tool itself. In the interest of time, let me sort of get to the point. Okay, so I think there's sort of three areas where this is relevant. The first is sort of what I've just mentioned, which is to facilitate the input process, that we would be curating data sets and so forth through this kind of integrated design tool. The second is in sort of the integration of whatever applications we're building with these trained models, so that one's, a lot of the tools today would either kind of go with a RESTful service or perhaps a messaging protocol to bridge independent systems like OSC. These are of course great solutions, but as kind of higher bandwidth systems come into play, like in this case, a real-time SLAM implementation, or kind of a mapping of rooms, it makes sense to start to integrate this kind of functionality natively into an environment in which we can build user-facing applications, so that people could build things, use a pose estimation model to connect like skeletal control in the character in their game, or an image segmentation model to build sort of their own image editing tool. Sorry. Okay, so finally, just to complete the loop, developers, also, as we have talked about with sort of the reinforcement learning thing in DeepMind and OpenAI, the sort of output of these applications can then become kind of new training input, so that we could look at user action histories to kind of learn models where we try to predict what they would want to do next, or use a physics environment to build training inputs for a reinforcement model. So finally, I'll just conclude by saying that the revolution in personal computers sort of only occurred when the tools, desktop publishing and so forth, became accessible and kind of made the need for computers relevant to the everyday person to build something for themselves. I think that this is very much the case with machine learning. Until we are able to kind of use these as tools to solve our own unique problems, we are sort of at the behest of pre-built services, and so it's very important for tools to be able to sort of connect with people's individual needs. Thanks.
Hi, thank you for that. I wondered whether you had any thoughts on two things really. One, which is forgetting, because a lot of what makes us human is also to be able to forget either methodologies for riding a bike that didn't work out for us, or people or events or spaces, and whether there is a role in machine learning for the idea of forgetting things. And the other element of that is whether, again, as humans, we're really terrible at quite a lot of different things. And so a joke that's doing the rounds on Twitter is, concerned teacher, should I throw myself off a bridge? Machine learning says yes, because, the data says yes. So where in machine learning and programmatically speaking, do we place decision-making, ethics, and even identification that something actually should never be, you shouldn't be doing this at all?
Thanks, that's a great question. I mean, I am certainly of the opinion that this is 100% about humans, and that these are tools to extend our reach. It's in a very different form, perhaps, than sort of previous tools. I guess, we could compare it to various previous revolutions, the Industrial Revolution, but perhaps maybe the sort of better comparison would be to compare it to the domestication of animals, perhaps. But it will go on beyond that, and I think we don't really know quite yet whether it's that or something much more, right? The question of whether we sort of achieve general intelligence in machines in any near term sort of will dictate whether we're talking more about the domestication of animals or something perhaps much uglier than that. And so, that I guess will decide some of the history in relation to your question. But I think for the time being, and without being able to know kind of where we will be in that respect, that the kind of things that we should be focused on are, ways in which people can sort of tack this onto tasks that they might have used perhaps computer science for previously, but in domains where basically sort of explicit procedure is just not effective. Oh, and as far as, yeah, oh, well, should I address the forgetting or take a?
Yeah, please.
Yeah. Yeah, I mean, like, so the task of creating a data set, it sort of depends on, again, sort of what mechanisms occur in the near term, whether we sort of get down to, you know, zero-shot or one-shot kind of learning mechanisms where we need far fewer examples. Obviously, it sort of plays a big role in like whether the curation of a data set is something where an individual can kind of go in and manicure things in that way. Of course, there are a number of mechanisms on, you know, say transfer learning, and also in the project that Alex showed, they're using k-nearest neighbors so that, you know, in the end, the number of examples that is needed is very small. So, I mean, it's a really interesting question. I think I haven't thought it through sufficiently, but I guess I could just say that, you know, that ideally, this kind of tool sort of puts it in a much larger group of people's hands, and therefore, you know, it is kind of not so enclave to people with one very specialized skill to kind of make these decisions for all of us, but instead that as each of our sort of own personal tool, we can start to kind of, you know, make the curations of what we want to remember or forget for ourselves.
Question here.
Sorry, me again. I think your work has interesting parallels with end-user programming, end-user software engineering, and end-user development for straightforward software or straightforward programs. I think that work has been around a number of years, and it rests on making programming environments easier for novices, but also it uses an understanding of what novices and end users without a background in programming struggle with, right? So we know that there are certain things in computational thinking that are really, really difficult to grasp. What do you think those challenges are for machine learning? What are the tricky things that ordinary users will trip up on and that they need particular support with?
Thanks. That's a great question. So, to go back to sort of the beginning of your point, you know, that those kinds of mechanisms exist in conventional programming contexts. I think one place where that can be a little misguided in how people kind of approach the simplification is to elucidate an individual mechanism in programming, like say a conditional or a loop. And kind of go into depth about sort of exposing that. But as programmers, you know, I think what we come to realize is that ultimately the thing that makes programming complicated is not understanding how an individual for loop works, right? But about how sort of many of these little granular building blocks all kind of have to work together in this very complex system, right? And so that's the real skill in programming is learning how to sort of put all of these little pieces together. So my sort of purpose in thinking about this directives concept is to try to address that in a way, which is to say that that it's not about learning sort of any one building block, but instead about sort of the big curation. And so the attempt with directives is to kind of think about a way of not specializing around any one use case, but sort of creating a mechanism by which we can guide ourselves or guide other people through complicated processes, not any one specific process, but that we have sort of if you will, a platform for doing that. So just to sort of wrap up the answer, I think you know, in machine learning, probably it is in spirit the same issue as it is in conventional code, which is that it's not sort of the issue of understanding any one little specific mechanism, but understanding how they all act together, right? So like understanding a perceptron, like a linear neuron, you know, is perhaps not too challenging, but it doesn't quite sort of scale up to understand why this sort of works when you're dealing with like many layers with like, you know, millions of connections between them.
Thank you very much.
So the last speaker is, and I'm going to pronounce it right, Kenneth. Excellent. Kenneth is a designer and an author, and he's been looking particularly at future ethics. He's been advising different companies like Samsung, Twitter,